So in today's video, we're going to go ahead and introduce the notion of integration by parts. And this is a bit of a more advanced integration technique, but really we're going to come to find that it's actually just very simple and very analogous to the derivative product rule. And that's actually where it's derived from. And so let's go ahead and see how we can come about this rule, this integration by parts rule. And let's really find out what it actually is. And so let's say we're taking the derivative of the product of two functions. So the derivative with respect to x of u of x times v of x. And we know that that's just going to be equal to u prime v plus v prime u. I removed the of x part because I just kind of wanted to make it a bit, neater and a bit easier to write down. And so let's go ahead, we have this equation over here, we have this rule. Let's go ahead and just apply the integral operator to both sides, the indefinite integral operator to both sides. So if we take the integral with respect to x of both sides, and we can just do this because this is like taking the derivative of both sides. It's just applying an operator onto both sides of an equation. And so if we do this, we kind of think of this integral and this derivative operator canceling out, if you will. Not very rigorous, but that's kind of essentially what would happen if we think of them as inverse operators. And then ultimately we'll end up over here on this side with u times v. I'm not going to write the of x part again. And then over here we have the integral of u prime v. I'm just going to write it like that. The integral of u prime v plus the integral of v prime u. Right, and again, I omitted the dx part over here, but you can write that down if you like. And then ultimately, what we can do is we can solve for one of these two integrals over here, for maybe this one. Let's pick this one, by just subtracting this integral of v prime u from both sides. And so ultimately we'll end up right over here with the integral of u prime v is equal to, I just switched it, is equal to u times v minus the integral of v prime u. And that right over there is our rule for integration by parts. Essentially, it tells us that if you're integrating the product of a function and the derivative of another function, it's just equal to the product of the two original functions minus the integral of, basically you just swap the derivatives. So here we had u prime v, and then here we have v prime u. So you just swap the derivatives and you just multiply the two functions by each other. And so it's another way to write this down if you enjoy having the notation. The full notation would be, the integral of the derivative of u with respect to x times v of x dx. That's just equal to u of x. That's u of x times v of x minus the integral of the derivative of v with respect to x times u of x dx. And so that's another way you can write it down, but we're just going to stick to this notation over here because this is probably the most common one you'll see in a Calculus 1 or Calculus 2 course. And so ultimately, this is essentially the integration by parts rule, if you will. And so let's go ahead and apply it because this is very abstract. Let's go ahead and apply it to a couple of examples to really see how this works. And so let's start off over here with the indefinite integral of x natural log of x. So essentially what we're going to do is we're going to try to identify our u and our v over here. And we're going to identify it in a way that makes the integration process a lot easier. And so let's go ahead and think. We want our u to be we want to have the derivative of u in our original integral over here. Now, natural log of x, there isn't really any obvious function that has a derivative of natural log of x. But for x, there is. We can just think if we let u prime equal to x, we'll know that u is just going to be equal to x squared over 2, right? And so it would be helpful to let x be our u prime in this case instead of natural log of x, because then we have to integrate natural log of x. That becomes a whole complicated issue. And then instead we can just say let v equal to natural log of x, and then v prime will just be equal to 1 over x, right? And so now we can go ahead and use this information, just input it into the equation that we defined above, and then we can just go ahead and integrate as we would normally. And so here we just need the product of the two original functions, so x squared over 2 natural log of x, and then we're going to subtract that from the integral of v prime u. Here we said v prime is 1 over x, and we know that u is just x squared over 2 dx. And so this right over here, we can just evaluate this integral on the side. This is just going to be equal to the integral of x squared over x. That just becomes x. We can take the 1/2 out if we would like. And so it's a very simple integral. We know that's just going to be equal to 1/2 times x squared over 2 which is equal to just x squared over 4. And then ultimately, we'll just put that back into this equation. So this is equal to x squared over 2 natural log of x minus x squared over 4. And then we just have the plus c at the end because it's an indefinite integral. And so that right over there would be our final answer. So essentially, the most difficult part really is just identifying what's a better u prime and what's a better v. And just think of something that's easy to integrate when you want to define your u prime. Because ultimately, you're going to have to like implicitly integrate it, if you will, when you want to input it into this integration by parts rule. And so make sure you find a function, one of the two functions that's easier to integrate to define your u prime. So let's go ahead and do another example. So here we're taking the integral of arctangent of x. And so here we don't really have, or I mean, it doesn't really look like we have the product of two functions, but if you want to think about it this way, this is kind of just 1 times arctangent of x. And so we know right over here, it's very difficult to find, or to immediately find a function whose derivative is arctangent of x. And so we can just take this 1 right over here to be our u prime. U prime is equal to 1, and so that very simply makes u equal to x. And so that's a very nice way to define u in this case. And really, it's just a matter of observing that when you don't really have, when it doesn't look like you have the product of two functions, you always have a 1 over there to help you out. And so arctangent of x, we can let that be our v. So v is equal to arctangent of x. And then we know that v prime is going to be equal to 1 over 1 plus x squared. And then we can go ahead and just put this information into the integration by parts rule. So we're going to take the product of the two functions, so x arctangent of x, and then we're going to subtract that from the integral of u, which is x, times v prime, which is 1 over 1 plus x squared, dx. And now we can just go ahead and integrate. So here, let's just take a look at this integral. We can make a w substitution if you want, since we already used u. So we can say let w equal to 1 plus x squared, and we can observe that because the degree of the numerator is less than the degree of the denominator, so this could be a good substitution to make. And so then we know that dw is equal to 2x dx. And so to evaluate this, we can bring a 1/2 outside, make it 2x over 1 plus x squared. Dx is just basic u substitution over here. And then if we substitute, we get 1/2 times 2x dx is just dw, and then 1 plus x squared is just going to be w. And so this is equal to 1/2 natural log of absolute value of w, and that's going to be equal to 1/2 if we want to back substitute natural log of 1 plus x squared. We don't really need the absolute value because this is always going to be positive. And so that right over there, and we can just put this all together, actually. That's just going to be equal to x arctangent of x, and then minus 1/2 natural log of 1 plus x squared. And then, of course, plus c. And so that right over there is our final answer. So really, again, it's all about identifying the proper u prime and the proper v to input into the equation, just to make the integration process a lot simpler, because you really don't want to overcomplicate it, actually. And so right over here, like I said, whenever you don't really see the product of two functions, always remember that there's a 1. And in general, just keep this formula in mind. For IB HL Math, I'm pretty sure you get this formula in the booklet. But really, again, all it is just identifying what's the proper u prime, what's the proper v to input, and then it'll drastically simplify the integration process. And so I hope this helps.